Hello and good afternoon, CTS265 Section 840 students for the Fall 2015 semester at Anne Arundel Community College. This afternoon's video tutorial is going to be the answer to the Week 7 challenge question. And the challenge question is presented over here to your left. So the requirements or the restrictions are, and what I need to know in order to win the contest is on which router will you place the prefix list in the distribute list, what is your one-line prefix list statement, and what is the one-line distribute list statement that is as specific as possible with respect to the router on which you've placed it from an interface perspective. And so as soon as you see that from an interface perspective, that's going to tell you that you're probably going to be indicating the interface at the end of the distribute list statement. So to begin, we're going to leverage the Learning Labs activity or discovery number 14, which was on OSPF v3. And again, these discovery activities are absolutely fantastic and a great opportunity for you to get in and not just do what the activity is asking you to do, but to sort of experiment with other technologies or other features that we're talking about, like distribute lists or prefix lists and route maps, access lists, things like that. So let's go ahead and dive in here. So you need to complete the first 4 steps in the Discovery 14 activity. So let's go ahead and knock that out right now. So the first step, and actually let me come over here to router 1. So the first step is to activate IPv6 unicast routing. So I'll say IPv6 unicast routing from global config mode. Then I'm going to say IPv6 router OSPF 1. And what this is going to do is this is going to put me into the OSPF v3 non-address family mode in order to configure OSPF for IPv6. So then I'm going to say router ID, and for router 1 we'll simply use 1.1.1.1. And then I'm going to passive interface loopback 0. So that was step number 1. Step number 2, we're going to go ahead and we're going to activate OSPF on a number of the interfaces. Keeping in mind that with OSPF v3 non-address family mode, that what we're going to want to do here is we're going to go into interface loopback 0, and we're simply going to say IPv6 OSPF 1 area 0, because that's the area for that interface. Ethernet 00 is also in area 0. And then we go into interface serial 20, and keep in mind that IPv6 OSPF 1, that serial 20 is in area 1. And this is critical because if we look at the diagram here, what we'll see is that we need to make sure that this adjacency between router 1 and router 2 is formed over the frame relay cloud. And this is the serial 20 interface here. So we actually have an extra step that we're going to be looking at here in just 1 second. So we want to make sure we get it into the right area. And then we're going to go into Ethernet 01, and we're going to say IPv6 OSPF 1 area, and this is area 2. All right, so we've got the areas configured. It seems to take a little while for the adjacency to come up between the routers here, between router 1 and the different routers. But let's say do show IPv6 OSPF neighbor, and we have full adjacencies with all of the routers right now. So we didn't see any messages pop up, but that's okay. So the adjacencies are there. So that was step number 2. Step 3 is to simply examine the adjacencies. Now here's the final step, and this is what we need to do under interface serial 20 is I need to say IPv6 OSPF neighbor FE80::2. Now I'm suspecting that that may have already been there, serial 20. Whoops. Because the adjacency did come up and it was in the full do show run interface serial 20. All right, so we've got that statement in there. All right, so those are the steps. That's all we need to do. So now if I go to router 4 and I say show IPv6 OSPF, or show IPv6 route OSPF. So as you can see, we've got quite a bit of routing information here on router 4. And if I bring back the routing table, you can see when you do the show IPv6 route, it shows you all of the information here. I thinned it out over in the router window there to just the OSPF information. So now your mission, should you choose to accept, is to provide me with the single line prefix list and the single distribute list that would result in the routing table on R4 matching exactly the output below. So if you were to say show IPv6 route OSPF, I only want to see that single address coming through, right? So this is all we would want to see. So how would we tackle that? Well, and let me go ahead and shrink this window here so we can see the information, and we'll still be able to see the router window. So how would you tackle that? Well, as you can see, it's only allowing a single route through. So the first question is, on which router will you place the prefix list and the distribute list? And this question actually came up. Why would you not put the prefix list and the distribute list here in the inbound direction on serial 20? And the question is, or I should say, and the answer to that is, remember that this is an area border router here, right? This is an ABR, and I can do a distribute list on an ABR. However, typically, if you want to short circuit all of that routing information from coming this direction on router 4, and you can see it actually kind of gave you the answer here. On router 4, I can do a distribute list here in the inbound direction as well. So we'll go ahead and do both, because again, it's a simple distribute list and a simple prefix list. Let's do both and let's see the results. So let me clear the screen. So first I'm going to come to router 1, and we're going to create a prefix list. So I'm going to say IP prefix list, because I know what I want to match, right? So we'll call this prefix list ABC. Sequence number will start with 9, let's say. And then I'm going to say permit. And actually, before we do that, I'm going to come all the way back here and say IPv6 prefix list. Permit 2001:0:222:/64. Now, the reason for this prefix list statement right here, remember, in the prefix list statement it says the /64 is critical, because this means that these first 64 bits have to match. What takes place after that, depending on whether we do the less than or equal to, right? If we're not using the less than or equal to or the greater than or equal to, then we're stuck where it has to match that exactly. Well, it just so happens that that is exactly what we're trying to match. So this prefix list is good to go. Again, remember, the length is critical because that dictates how many of the bits need to match. And so every IP address that this is going to match has to start with 2001:0:222, right? So no matter what we match, it's got to start with this. And again, it just so happens that that is exactly what we're looking for. So there is my prefix list. So now what I would need to do is say do show run. Let's take a look at section OSPF. So there's my IPv6 router OSPF 1 configuration section. So let's go ahead on the ABR router 1 and say IPv6 router OSPF 1. I'm going to say distribute list, and then what do we put? We're using a prefix list. And what's the name? It's just simply ABC. Now, is this in the inbound or the outbound direction? Well, we know it's in the inbound direction. And I also know that it's coming in serial 20. So I'll go ahead and hit enter. On router 1, let's say do show IPv6 route. And actually, let me see, do show IPv6 route OSPF. So you can see that we see these two intra-area routes here, but then we only see that single route. Now let's go over to router 4 and see what router 4 sees. So we'll say show IPv6 route OSPF. And what do we see? Did it do anything on router 4? It did not, right? It did not do anything on router 4. And the reason is, remember that the inbound distribute list does its filtering before the route goes into the local routing table. So let me hover over the diagram here. So and what I'm saying is, all of these loopback addresses here are coming in from router 2 into the ABR, which is router 1. But remember, a distribute list in the inbound direction, right? When it's in the inbound direction, it does its filtering after SPF and the link state database have already updated. So if the requirement was for you to make the router 1 routing table look different and to filter things out, this would have been your answer, was your distribute list in the inbound direction on serial 20, matching that single route in your prefix list. However, the link state database has updated, SPF has already run, and as a result, since the link state databases need to be in sync, the LSDB here already flooded its type 3 LSAs outbound to router 4, and so router 4 will get all of that information, right? So, because to draw sort of a little image here, so here comes your routing information, right? Or this is your link state update coming into the router. We'll say this is router 1. So the link state update comes in, SPF runs, the link state database gets updated, and then the distribute list is evaluated. So all of this has already happened prior to the distribute list being run. And the reason for that is that it guarantees that the link state database is the same throughout the OSPF area. And it only impacts, this inbound distribute list only impacts router 1. So if I only wanted router 1 to see that single route, this would be the solution. So now let's flip it. Let's put it in the outbound direction here, and let's see what happens. Would that be a possible solution? So we'll come back over here. We're going to recall our command on router 1 with the distribute list, and we're going to say no distribute list prefix list ABC in serial 20, do show IPv6 route OSPF. So now I've got all of my intra-area routing information, because remember, router 1 has an interface in area, I believe it is 1. Yes, in area 1, right? So here we are back on router 1. So let's put that distribute list statement, distribute list, and then prefix list, right? Because remember, we used a prefix list. It's IPv6. We can't use an ACL there. Has to be a prefix list. Prefix list name was ABC. And we want to do it in the outbound direction. And we're going to do it, we actually can't say, or we can't use the interface, right? So when you look at this, what's the problem here? Exactly. I can't specify the outgoing interface because I'm not redistributing external routing information. So remember, that's the limitation of doing a distribute list in the outbound direction in OSPF. The first requirement is that the router has to be an ASBR. So if I say do show IP OSPF, or do show IPv6 OSPF, what kind of a router is this router? This router, it is an area border router. It is an ABR. And an ABR does not give you, and that's supposed to be some equal signs there, does not give you, in fact, let me pull that back. So it does not give you an ASBR because we have no external routing information at router 1. Therefore, router 1 cannot do the filtering in the outbound direction because it's an ABR. It only has routing information internal to the OSPF domain. He's got an interface in area 1, an interface in area 2, and an interface in area 3. And we're not redistributing any information here. This is all internal OSPF information. Now, some of it's intra-area for router 1, right, because he has interfaces in those areas. And then some of the information, like the information coming from area 1 and 2 over to router 4, is inter-area traffic. So we did the distribute list and the prefix list configuration. We did it on router 1 in the inbound direction. We saw it didn't work, and we know that's because of the order of operations. That the link state database gets those link state updates, it does its SPF calculation, it floods the LSAs, and then it looks at the distribute list. So the link state database has already been updated. So it's going to flood to router 4, who's going to ignore this inbound distribute list here. We just tried to do it in the outbound direction, and it won't work because we're an ABR. Router 1 is not redistributing any routing information from an external source. So I can't do it in the outbound direction because remember, in OSPF, if you're using a distribute list, in the outbound direction, there's two requirements. The first is it must be an ASBR and it must be external routing information. If it's not, it will not work. So we've tackled it from router 1's perspective. This pretty much leaves us with only one option left, and that's over here on router 4. And again, had you looked here, this kind of gave it away as to where you would place the prefix list and the distribute list. It would be on router 4. So if I were to go to router 4 and say, let's confirm we're still seeing all this information, take a look at all that inter-area OSPF routing information, all those type 3 LSAs flooding into router 4. And on router 4, let's go ahead and say IP prefix list, IPv6 actually, stuck in the IPv4 days. So IP prefix list ABC sequence number 99 permit 2001:0:0:222//64, and then let's say do show run section OSPF, and here we are doing OSPF v3 with address families, right? So a little extra challenge here where we're going to say router OSPF v3 1, the process ID 1. This is the address family IPv6 unicast, and what are we trying to do? A distribute list. Again, it can only reference a prefix list because it's IPv6. What is the name of my prefix list? It's ABC. And which direction? Well, we know it's not outbound, right? Because it would have to be an ASBR, and we'd have to be talking about externally generated routing information from router 4. And that's not what we want to do here. So we want to get it in the inbound direction after the link state update and the link state database have run the SPF calculation and have completely converged. They're identical throughout the area. Then my distribute list, which calls my prefix list, says in the inbound direction on Ethernet 0, and is it, I think it's 0, 0, Ethernet 0, 0. All right, so there we go. Now, let's say do show IPv6 route OSPF, and does that match this routing table? It does, exactly. Right, different link local address, but that's okay. But you can see, right, we have a single inter-area OSPF route, and we limited it or constrained it down to the 2001 DB8 50222:/64. So, on which router will you place your prefix list and distribute list? We've answered that. That's router 4. What is your one-line prefix list statement? Do, show, run include prefix list. It's that right there. And there's our distribute list statement along with it. And there's the one-line distribute list statement. All right, so if you got those answers correct, you successfully answered this question. So make sure, again, if you see opportunities in these discovery activities, which are absolutely fantastic, make sure to take advantage of that. Spend a little extra time and experiment. Try to get in there and try to use the technologies and the features and functionality that we've been talking about. And remember, if you get stuck, it's no harder than going to manage devices. And as soon as it comes up, just say reload config all. And this will put all of my devices back to the original configuration. Just as simple as that, and then I start all over again. All right, well, this was challenge question from week number 7, and I will see you all on Monday.